Hello guys, thanks for tuning into my unboxing and testing video. I have here a Rockpals Rockpower 500 backup power station. Essentially, it's a very large lithium-ion battery that's supposed to be 500 watts peak output. I actually believe the peak surge or the temporary peak output is 750 watts, and the sustained continuous wattage is 500, and this is rated through the AC adapter. But anyways, let's go ahead and unbox it, see what's inside, and then we'll start doing some testing to see if it really lives up to its claims. So let's see what we got in here. Very top, looks like we got some connectors here. Looks like we have a 12-volt car charger. This is the AC adapter. Just looking at this AC adapter power supply, looks like it's going to be it outputs at 24 volts at 3 amps, or about 72 watts. What else do we got here? A couple informational cards, a little quick user guide. This little cheat sheet tells you how you can recharge it. You can have up to 3 inputs at a time, it looks like. And quick instructions on how to use the outputs. Let's see what else is in here. Looks like we got the device itself here. It's pretty hefty. Seems quite solid. I don't hear any rattling. It's pretty much all heavy-duty plastic on the outside. On the bottom, it does have a couple feet with these protective coverings. Take all that off. The rubber is pretty grippy, and we see a PS500. I'm assuming saying power station. Looks like a couple fan vents on one end, and more vents, and you can actually see a fan at the very top here. On the front of the device, well, looks like there's a quick charge USB 3 here on the top right. This is a USB-C. You have 2 AC outlets with these waterproof covers, I'm presuming. Doesn't seem very hard to open. It does have a little slip on the edge so that these covers will actually latch on and stay on. There's a couple buttons to turn on each separate port. Here you have your regular USBs. They're labeled 5 volt 3 amps. This looks like a 12 volt output for your car adapters. You can directly connect your solar panels here, I believe. And these are inputs on the top right here, and these are 12 volt outputs using the ground plugs. And here's a button for the DC outputs. Now here is the power and the display buttons. I'm going to just turn this on. %65% out of the box. Not sure how long they've been sitting in a warehouse, but that's a good amount. Hitting the display just changes the percentages on and off. And we can turn on the USB. It actually tells you how much watt it's putting out. Interesting. Okay, well, it's pretty straightforward. Let me go ahead and fully charge it, and I'm going to start with some tests to check out its capacity and if it can really put out that much wattage. Okay guys, here we go. We have the battery pack completely charged, 100%, currently at 2 outputs. I have a TP-Link energy monitor hooked up to this heater. This heater has 3 settings. On low, it's supposed to draw 400 watts, medium is 600, and high is 1200. So I'm going to put it on low and let's see if we got a consistent 400 watts. I also have the app on my phone for this TP Link monitor, and currently we have 1.82 watts. We can measure total consumption, and we can also see the consumption on the battery pack. So let me go ahead and get this started. I'm going to start the timer, and I'm going to see how quickly as it goes down, we're going to see if it consistently keeps on putting out 400 watts, and also how quickly it gets drained, and then we can calculate the capacity. Okay guys, we're at 50%. Output is getting up to 500 a couple of times, and again, still going strong without any shutdowns. Time so far, 41 minutes and 50 seconds. We'll go ahead and run it all the way down. Well, color me impressed. This is down to 25%, and output has actually topped 500 watts, and it's still running strong. So far, timer is 55 minutes. We'll go ahead and keep on going until it's completely out. Okay, so we finally hit 10%, and the battery is not able to output 500 watts, which is expected. As batteries get lower in voltage, it has a harder time powering the inverter. We're going to have to finish up the rest of the test using lower draw devices. But so far, timer was 1 hour. Sorry guys, since the AC inverter wasn't powering on, I couldn't get the consumption numbers from the TP-Link plug, so I pulled it out and put it into another outlet, and at 10% remaining capacity, it drew out 400 kilowatt or 400 watt hours. Okay guys, so I was able to completely drain it from 10% down to 0 with about 30 minutes of the air compressor. Sorry, it was pretty loud on that prior video, but yes, you can use the 12 volt and USB DC outputs even though it's less than 10%. Just the AC inverter is not capable of functioning with that low of a battery voltage. Anyways, now I'm going to go ahead and start charging this. You can see that the total consumption from the plug was about 400 watt hours, and this was just from the heater. The 10%, I will have to calculate that at the very end. But anyways, I have my TP-Link output on here. I'm going to go ahead, plug this in and start charging it. See what the round trip efficiency is and how long it takes to charge. Anyways, let's go ahead and plug it in. Input. $67 watts. So let's start our timer. Okay. Although it does say 67 watts in the input, notice that the power draw is actually 80 watts on the TP link. And there's a couple reasons for why there's a discrepancy, and we'll discuss that after everything's charged up. Okay, I'll come back and see when it's completely full. Okay, looks like we've hit 100%. Took about 8 hours. And total consumption from 0 to 100% on charging went from, remember it was at 0.4 kilowatt hours, so about 620 watt hours to fully charge it. Anyways, let's go ahead and break everything down and look at the numbers. Okay, another minor test that I just did right here. I turned on the battery backup and to turn on the AC, but actually did not plug anything in to see how long it would take before it auto shuts off. Anyways, I got tired of waiting, but it's been almost an hour and it has been on the whole time. And this is usually a problem with plugging in things that intermittently draw power. I know some battery backups will actually turn off after a short time of inactivity. And so when you have like a 12-volt refrigerator, when the compressor turns off, the battery backup will be off by the time it turns back on. And of course, you're going to lose power. So this is actually pretty good. It's been on for over an hour, or close to an hour now. And so you can have things that intermittently draw with no worries that it will shut off midway. Okay, let's explain these numbers really quickly. So this charge, I went from 100 to 10% at about 400 watts for about an hour, and we got 400 watt hours. I know my heater was more draw than 400 watts. It was actually going close to 460 to 500 watts, but unfortunately it turned on and off intermittently, probably because either the heater was reaching the temperature or it was just taking a break since it's an oil heater. Either way, I've averaged it based on how long it took to get there and how much my energy monitor said was drawn out. So from 10 to 0, I had to switch over to using a DC air compressor. I had an 80 watt air compressor, and it took me about half an hour of on and off usage for it to completely drain the battery from 10 to 0%. So 40 watt hours. Total is 440 watt hours. And I know you're thinking, wait a minute, this is way less than the advertised capacity. But in fact, it is the advertised capacity, because you have to factor in inefficiencies and other things that I'm about to talk about. So if you have the advertised capacity, which is 505 watt hours, you have to understand that these AC inverters and DC to DC inverters, to convert it to whatever usable voltage compared to battery voltage, is not entirely 100% efficient. It's about a 90% efficient capacity, which is kind of standard. You get 454 watt hours. The other thing you have to know is that while I was doing these high draw from the AC, the two cooling fans inside the device actually were powered on the whole time. So if you give it about an hour for when it was using the AC, I've looked at the side of the fans and they are 9 volt 0.3 amps, and there's two of them. So if you count 1 hour of usage, well, it turns out that the total capacity, accounting for the inefficiency of the inverters, well, it's very close to exactly what I actually measured in terms of pulling out from the power station. So it's actually quite accurate in terms of the capacity. Now, let's move on to the charging. We can talk about how efficient the charging is here. Let me move my pointer here. From 0 to 100%, it was about 70 watts. Took about 8 hours. Then I know the numbers don't exactly match up completely, but from my energy monitoring device, it came out to 602 watt hours. Now, you're going to be saying, well, wait a minute, the capacity is only 505 watt hours. Where did the one extra 100 watt hours go? Well, at the top right, remember it took 8 hours, and during the charging, I noticed that even though it was charging from the AC adapter, both fans were on for the whole duration of the charge. So 8 hours at the 9 volt 0.3 amp fans. Turns out it's a lot of watt hours. It's actually 43 watt hours for 8 hours of the fan cooling the batteries while it was charging. So now the actual input into the battery was 558 watt hours out of a total of 505 watt hours, which gives an efficiency about 90%. And again, that is actually pretty accurate for a standard device for a AC to DC adapter. Remember, this was using a AC brick, and that AC brick gives off some heat. Well, that's where all the extra heat is. So overall, round trip efficiency is 81%, and that is actually pretty standard for consumer devices. So the numbers actually check out, and the capacity is actually what is advertised. Okay, well, there you have it. All the numbers crunched out, and it seems to actually match up with the capacity, plus or minus a few percentage points because of the assumptions that I've made. But overall, what you get is what is advertised. Overall, very well built device. As long as you know what you're getting into, you shouldn't be disappointed. Main things I would have to point out, the limitations. First of all, the 10% was described in the manual, and if you are less than 10% battery capacity, it will not power the AC inverter. So that is explained very well in the manual. Also, the lack of pass-through charging. You can use the DC ports, the 12 volt or the USB ports while it's charging, but you cannot use the AC inverter. So if that's a deal breaker, you might have to look for another device, but if that's not a big issue for you, this would be a perfect item. Anyways, I run my battery of tests. Yeah, I know, I'm sorry about making that pun. And there you have it. Thanks for watching. Hope this was very helpful in making some informed decisions for yourself.